So, today I'm going to be talking to you about exponential growth.
Base. Davai.
So, the equation for exponential growth is y equals a times b to the x over n. Y is the final amount. A is the initial amount. B is the growth factor. X is the time, and n is, it's kind of confusing. It's basically like if it says that something doubles every 3 hours, then the growth rate would be 2 because it doubles, and every 3 hours n would be 3. So it's basically a unit of time. So y equals a times b to the x over n. I think you got it. So we're going to be doing at least one problem. So this one's about population, about petri dish actually. Suppose a culture of 100 bacteria is put in a petri dish and the culture triples every 2 hours. So first we'd have to write an equation. So the starting amount is 100, so we don't know the final amount. So we would write y equals 100, parenthesis. The growth rate says the culture triples every 2 hours. So triples, the growth rate would be 3. X, well, we don't know x yet because we're going to plug some stuff in later, so just leave it as x. And it triples every 2 hours, so 2, as long as we keep x in hours. That'll work. So using this equation, how many bacteria will there be after 24 hours? So after 24 hours, that's pretty easy. So 24 is x, 2 is n, so it would be y equals 100 times 3 to the 12th, because 24 over 2 is 12. See? So then you're trying to solve for y, so basically you have to plug it into your calculator. So 3 to the 12th times 100, 53,144,100 bacteria. That's a lot of bacteria. So that's one way to do it. And then you can you do a lot of things with this equation. Like, it can ask you how many there will be after a certain amount of time, or how many hours will it take to reach a certain number, or it can ask you to find the growth rate. It can ask you a lot of different stuff. So how about, after how many hours will the number of bacteria reach 10,000? So for that, now you know your y. Your y is 10,000. So 10,000 equals 100 times 3 to the x over 2. So for this one, you're going to have to use some logs because you're using some weird exponents. Start off though, because you see this is the equation. You're going to want to divide the 10,000 by 100 to simplify it as much as you can. So 10,000 divided by 100 is 100. So 100 equals 3 to the x over 2. So after this, you log both sides, which we've already learned. So log base whatever of 100 equals log base whatever of 3 to the x over 2. And we learned that you can move the x over 2 to the front. So your equation would look like that. And then to solve for x, you would divide log base something of 100 by log base something of 3 equals x over 2, and then you multiply the other side by 2. So your final equation would be x equals 2 times log something of 100 over log something of 3. And to put it in your calculator, which is pretty much the only easy way to do this, you just leave it as log 10, because log base 10, because that's your calculator's default, so it makes it a lot easier. So you plug it into your calculator, log of 100 over log of 3 times 2. So x equals 8.384 hours. See? So that's how you do that problem. It's pretty much applying the log stuff that we've already learned in this unit, just adding another equation that you have to algebraically solve. So it's pretty simple stuff, but it's kind of fun if you know how to do it. And then another thing you can do with this equation is that shows up a lot, like I saw it a lot back in Algebra 2 when we did this type of stuff, is half-life. So half-life, it's basically y, you use the same equation, y equals a times b to the x over n. Y equals whatever a to the b is 1/2, because it's half-life is how long it takes a substance. It's basically with chemistry. It's how long it takes a substance to reach half of what its original amount was.